All right, so here we are, we're on chapter 6, refrigeration systems. A lot of critical thinking questions. How to continue writing on the next page. Let's get it going. Cool. All right, so first question, number 1. Blank refrigerant is like a dry sponge that has the ability to soak up a lot of water. That's going to be a low pressure liquid. And that's on page 85. Number 2 is blank refrigerant is like a soaking wet sponge that cannot absorb more water. That's going to be low pressure vapor, B, and that's going to be on page 86. There's a chart and there's a paragraph for that one. Number 3, from the metering device to the evaporator to the compressor. From the metering device through the evaporator to the compressor is the blank side of the system. That's going to be low, page 86. And there's a chart there as well, a picture, a graphic. 4, the compressor exhausts through the condenser and liquid line to the metering device is the blank side of the system. That's going to be the high side of the system, B. That's going to be on page 86. So 3 and 4 are both on page 86. 5, using suction, a compressor draws in refrigerant by creating a blank in the evaporator. That's going to be low pressure, page 87. Using the process of compression, a compressor increases refrigerant, blank. This one's on page 88, and it's pressure and heat. That's really what we're doing. So A, B, and C all have the word volume in it. So that was one of the tells that it wasn't that. 7. Commonly used in different HVAC applications. Blank compressor uses a back and forth or up and down motion. That's going to be reciprocating. That's going to be on page 88. A heat exchanging device designed to expel or reject heat is a blank. That's going to be a condenser. An accumulator is basically a storage tank. That's on page 94. An evaporator, B, wasn't the answer because it absorbs heat. Which is the exact opposite of the question. And then liquid receiver is another storage tank, and that's on page 90. So the answer is D, condenser. That's on page 90 as well, because condensers are going to remove heat. Now it says by releasing heat, meaning going from vapor to liquid, all right? Vapor to liquid, because vapor is the highest level of state. So there's 3 states of water. You got solid, you got liquid, you got gas. So when water is a solid, that's the coldest temperature. Then as you add heat, it turns into a liquid. And then as you add heat, it then turns into a vapor. And that same way goes in the reverse. So if it's vapor and we remove heat, it's going to go from vapor to liquid. If we remove heat, it's going to go from liquid to solid. Number 9, a condenser that uses a fan to remove heat more quickly is called a blank condenser. That one's on page 90. It's forced air. The reason it's not static, A, is because static and C, natural convection, are the same thing. They're basically just put the same answer, the option there twice. And then water cooled isn't, because it's using water and other forms of tubing. The only one that actually uses a fan on this list is forced air. All right, see what we got here. 10, heat flow can be described as, they talk about it on page 86, but you know that heat flow is going to go from hot to cold. So I gave the same analogy, like you put a warm can of soda inside the fridge. It isn't, the heat from the can is going to leave the can and go to the cold. So heat is removed. So heat goes from hot to cold. Hot to cold. It doesn't go from cold to hot. Heat goes from hot to cold. A storage tank for liquid refrigerant, we're at 11. A storage tank, we just talked about 2 tanks and a couple questions back. For liquid refrigerant on the high side of the system is what? That's going to be D, liquid receiver. That's on page 90. So liquid receiver is a tank. The accumulator is also a tank. That's on page 94, but it's on the low side. So accumulator is a tank, but low side, and liquid receiver is a tank, but high side. So the answer is D, liquid receiver. 12, refrigeration system with a blank metering device does not use a liquid receiver. That's going to be A, capillary tube. That's on page 91. Number 13, into which tank can a technician pump a refrigeration system's entire refrigerant charge to perform service? That's gonna be a liquid receiver, page 9D. All right, the high pressure line between condenser and meter device is called the blank liquid. It's the liquid line that's on page 91. The discharge line, the reason it wasn't discharge line is because that connects the compressor to the condenser. So liquid line, page 91, 14 is 15. To protect the system from dirt, moisture, metal, and other debris, install a blank filter dryer, page 91. A heat exchanging device designed to absorb heat is a blank evaporator. Evaporators absorb heat. The instantaneous evaporation of liquid refrigerant in the evaporator is called flash gas. That's page 90. I mean, it kind of spells itself out, but it's on page 91. That's what I meant to say. Page 91, flash gas and instantaneous evaporation. All right, 18. A storage tank that traps liquid refrigerant on the low side of the system is a blank accumulator. Remember, it's a storage tank, and it's on the low side of the system. And we know that the accumulator, then we know that the liquid receiver is a tank, but it's on the high side. That's on page 90. Accumulator A is the answer. That's on page 94. An accumulator, number 19, an accumulator will function best with its inlet positioned at the top of the tank. Page 94A. A at the top of the tank. Number 20, the blank line carries refrigerant vapor from evaporator to condenser. That's going to be the suction line. Page 94. All right, so now we're on the critical thinking. Number 1, which state of refrigerant, so that's key, state of refrigerant, liquid, vapor, gas, a liquid, vapor, well, it won't be solid. Which state of refrigerant is capable of absorbing the most amount of heat among the following 4 options: high pressure liquid, high pressure vapor, low pressure liquid, low pressure vapor. Select the correct answer and explain why refrigerant in that state can absorb the most amount in BTUs. This is on page 86. It's the answer is low pressure liquid, and the reference is the dry sponge. Lower at this, it has, because of low pressure liquid, it has a low, and the reason why it will absorb most heat because it has a lower boiling point, which allows some of the refrigerant to evaporate, equaling an absorption of heat. Explain at least 3 ways that heat can enter a refrigerator. Now, this answer I Googled because I couldn't find one, and I put conduction, convection, and radiation. I don't know if that one's correct, man. But yeah, moving on. Conduction, convection, radiation, the 3 forms of heat transfer that it talks about. I think that was the last chapter. Explain the 2 functions of a compressor as they relate to the low side and high side of the HVAC system. That one's right there on page 87. All right, so the first thing that a compressor does is it creates suction to draw out heat-filled refrigerant vapor. So first thing it does is it creates suction to draw heat-filled refrigerant vapor from the evaporator on the low side into the compressor. The second thing it does is the compressor compresses refrigerant, which causes high pressure and high temperature. The refrigerant vapor leaves the discharge line and enters the condenser as high temp, high pressure vapor. And there should be a way to do closed captions on the YouTube if you need a pause. So there should be a little kind of look like a setting. No, it should say CC and then in a square on your computer, your TV, or your phone, and captions should auto-generate. I know sometimes I slur my words, so they may not get it exact. All right, now we're on number 4. Explain why the discharge line is smaller than the suction line. What does the size difference indicate about the condition of the refrigerant within these 2 different lines? Is there anything else different about the refrigerant in each line? So we're on number 4, so critical thinking. So this one's gonna be on page 88. The discharge line is smaller because vapor has been compressed to a smaller volume at a higher pressure and higher temperature. The discharge line contains superheated vapor at high pressure, page 88. Suction line, page 94, suction line contains refrigerant vapor from evaporator to compressor, low pressure side. Number 5, name the 2 types of air-cooled condensers and explain their advantages and disadvantages. So we just talked about that in the previous question. The first one is going to be, they're both on page 90. Forced air condenser, I put, has fan, removes heat more quickly, period. The second one is natural convection, which doesn't use the fan, but it cools by the flow of air, period. So I guess you could say I didn't put any disadvantages in there. So you might have to come out your own. I looked. Actually, I could just, give me 1 second. I can Google this. I wanted me to like make this, add advantages of forced air condenser, I think it's condenser, 1 second. Condenser. All right, so the answer I got, forced air condensers, while common, do have several disadvantages. Potential for uneven heating and cooling, higher energy, yeah, I could see that, higher energy consumption compared to some other systems, and the possibility of reduced indoor air quality if not properly maintained. So you got 3 there. You got 3. So that's for forced air, and then natural air, natural convection. Natural convection coolers commonly used in smaller refrigeration systems have a few key disadvantages. They require a larger surface area for heat rejection compared to forced convection condensers, leading to an increased size and cost. They also operate at a higher condensing temperature, which can result in increased compressor power consumption, which obviously will burn through it quicker over time through that compressor. Cool. So all these are all those. So I guess I really didn't do an advantage. I kind of just explained it and gave it 2 facts for each one. So I guess you could say for natural convection, what are the advantages? It results in quieter operation, lower maintenance, and reduced energy consumption. For the natural, yeah, because there's no fan. So those are 3 positives. And then for the forced air, they can rapidly heat or cool spaces, improve indoor air quality through filtration, and are often more affordable to install. I got to figure out which one said it had a worse quality. I know they added the word filtration, but so we'll just rapidly heat or cool. That's a positive. And then more affordable to install if ducts were already in place. Oh, and they got more deep. Damn. Oh, I could have just gone down. Okay, cool. All right, let me go back to where we're at. We're at number 5. Name 2 types of air-cooled condenser. Okay, we just did that. Number 6. Explain how a metering device reduces the pressure of liquid refrigerant in the evaporator. So that's number 6. And I have number 6. It'll be on page 93. By allowing a small amount of liquid refrigerant to pass, little liquid added to more space equals less pressure. I mean, I think it's a little model. So what you're doing is, the way it lowers pressure is that as it's coming in, it just releases a little bit of the vapor into here. But by doing just a little bit, there's all this extra space up here. So when you add something pressurized into this, because you're adding it to a place where there's significant amount of space, the pressure will drop. It's because there's a lot of space. So the biggest thing is that it only releases a small amount of liquid refrigerant. and that's why there's less pressure on the system. Little liquid, lots of space equals less pressure. All right, 7 is page 94. Let me reread the question. Explain how an accumulator, which remember it's a tank, prevents liquid refrigerant from reaching the compressor. Page 94. It has an inlet outlet, basically like a valve. Any liquid refrigerant, so that's number 1, it has an inlet outlet, that's how. And then continue on, any liquid refrigerant that flows into the accumulator falls to the bottom must evaporate in order to enter the suction line, period. All right, that's everything.